Well, I have to apologize. I ended the last demo talking about carboxyl groups like they were coming up right away, but instead, they're going to try to kill us with alcohol for a little longer. So, continuing where we left off, we're going to be finding primaries and then saying where the hydroxyl groups are attached. Here I see 3 carbons in a chain, which would normally be propane. But because of the hydroxyl groups, this is going to be a propanol. There are 3 hydroxyl groups, so it's not just propanol, it's propantriol. And where are they? There's one on carbon number 1, one on number 2, and one on number 3. So propan 1, 2, 3. Sorry, a bit crowded. Propan 1, 2, 3 triol. Take care of that one. I hope this doesn't make you think benzene. It doesn't have the circle in the middle. When you just have 6 carbons in a hexagon and single bonds all around, that is, remember, it's sort of hexane. It's cyclohexane. But wait, it's not just hexane, it's got a hydroxyl group on it. So instead of hexane, it's hexanol. And normally a number would go there, but we don't need it because there's only one branch, so it would automatically be on carbon number 1. So, sorry, let me write that a little less awkwardly. Cyclohexanol should be all we need for that. If you say cyclohexan one all wouldn't be crazy, but it would be unnecessary. And then they give us another ring here. What is this? Pentanol? Cyclopentanol? 5 carbons in a ring is cyclopentane. OH makes it an alcohol, so cyclopentanol. There are 2 of them, so diol. And they're on carbons 1 and 2, if you number this right. Cyclopentan 1,2-diol. Here, okay, this is not a carbon, it's the OH, so we have 1, 2, 3, 4, 5, 6 carbons in our primary. That would normally be hexane. Hexane, but instead of hexane, it's hexanol. And the hydroxyl group is on the very first carbon, so hexan-1-ol. That takes care of all this. And then we have 2 branches. They are methyl groups, and they're on carbons 2. This is carbon number 1. This is not 1. This is the hydroxyl group. So 1, 2, 3, 4. So we have 2 methyl groups on carbons 2 and 4. So 2, 4, sorry, that's a comma. 2, 4 dimethyl hexanol. That's as skinny as the pen gets. Sorry, I'll have to allow myself more space so you can actually read what I'm doing. 2,4-dimethyl hexanol for that one. And another ring. This is 4 carbons. 4 carbons is butane, so when they're in a ring, it's cyclobutane. But instead of writing the E ending, I'm going to write cyclobutanol. And there's only one hydroxyl group, so automatically it's on carbon number 1, so no need for a number, just cyclobutanol. And they keep getting worse. What is our primary here? 1 carbon, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 9 is nonane. only we chop off the E and put all. Nonanol has got to be one of the worst names I've heard today. Okay, so nonanol, and because this is on the first carbon, this is now officially carbon number 1, it's nonan1-ol. In that case, the 1 actually almost helps. Okay, so nonan1-ol would cover this whole primary here, and now we have to manage the branches. We have 2 carbons there, that's an ethyl group. Also an ethyl group, so this is a diethyl. And where are those branches? This is carbon number 1, that's 2, so 3 and 4. 3,4-diethyl. 3,4-diethyl nonan1-ol. This one's hard to read. The spacing is weird. But anyway, we have an OH functional group, so it's an alcohol. They aren't trying to trick us. And our primary is 1, 2, 3, 4 carbons. 4 carbons is butane. But instead of butane, we're going to call it butanol. And the hydroxyl group is on the second carbon, so butan2-ol. And, oh, I'm sorry. Glad I double checked. It's not as simple as it looks. There are 2 hydroxyl groups. So, instead of butanol, it's butanediol. And where are those? They're on carbons 2 and 3. So butan2,3-diol would be more like it there. Double checking, good. Paranoia, good. Complacency, bad. Okay, this is also a diol. We got an OH there and another one there. And our primary is 1, 2, 3, 4, 5 carbons long, so pentane. If it was just this, it would be pentane. Because of the alcohols, it's pentanol. And because there are 2 of them, it's pentanediol. And they're both on the second carbon, so pentan2,2-diol. Good. 2 more. All right. Here our primary is this hexagon in the middle. That is cyclohexane. Cyclohexane. But I'm not going to write the E. I'm going to write cyclohexanol. Oh, I'm going to need more space than that. It would be cyclohexanol, but there are 3 hydroxyl groups, so it's cyclohexantriol. And those are on carbons 1, not 2, 3, not 4, and 5. So cyclohexane 1, 3, 5, triol. And last one. Here we have our primary is 1, 2, 3, 4, 5, 6, 7 carbons long. That would be heptane, if that were the whole story. But it's not. It's heptanol. There are 3 hydroxyl groups, so it's heptantriol. And they are on carbons 2, 4, and 6. So heptan 2, 4, 6 triol should do it for that last one. Okay. Now we're done naming alcohols. I'll see you in the next thing where they will give us alcohol names and we get to draw them. It'll be great.